Okay, so as you might imagine, I am pretty new to the idea of studying fish behavior. Why fish?
Why fish? I mean, personally, it's because my parents immigrated from Taiwan to New York City back in the early 1970s. I was born in Brooklyn, and on the off day from the restaurant, I would follow him out to the East River or Prospect Park. We'd fish. That's what he loved to do in Taiwan. I think I just developed this natural curiosity from the natural world through fishing and just never got out of that phase.
I'm Lacey Healy. This is Things That Go Boom. And recently I met Jimmy Liao.
I'm a professor of biology at the University of Florida, and I study how fish swim.
He's also a pretty accomplished angler. There's this one photo where he's maybe 10, and in each hand he's got a gigantic bass. They're bigger than his head.
I caught both of those fish at a local pond, and I remember distinctly there was a group of, it seemed like businessmen, and one of them offered to pay me $5 to put the fish back. And I felt kind of guilty because I didn't want to do it.
So instead, Jimmy walks all the way home, fish in hand, and he marches straight into the bathroom.
I just filled up the bathtub and I put these bass in there and I sat on the washer and dryer and I would just watch them swim around. And I just was so enamored with watching these fish that I made my family just not take a bath or shower for 3 days. That was after that they mutinied and they said we gotta let these fish go. But there's just some fascination that I didn't know what to do with them. I just wanted to see them and be around them and be close to them.
Just to be clear, we're not here to talk about fishing, but we are here to talk about fish and foreign policy. And to get there, we have to go back to this one moment in Jimmy's life from 15 years ago, when he found himself writing an essay for the NPR program, This I Believe.
I think it's at its simplest form. I was like, what is it that I know? What is it that I feel qualified to talk about?
As a graduate student, Jimmy had discovered that the currents in the water can actually sometimes throw fish off, like the aquatic equivalent of hitting a pothole.
But if it comes across in the right patterns, then I found that fish kind of adopt this new way to swim that people haven't really characterized before.
Once they feel the turbulence coming,
they let the vortex carry them in a way that they can shut down their muscles that they normally would use to swim. The idea is that there's a current, you're swimming upstream, and it's a lot of work, and then all of a sudden you catch the wave just right, and all of a sudden you can surf.
And in this surfing, Jimmy saw a life lesson.
What's the turbulence in my life? My parents grew up in a different generation, and they were in a different culture in New York City. And because of that, the communication with my father in particular wasn't very good.
Our best times together were spent trying to catch a fish. But there was another side to my father. He had a temper, and sometimes he got angry and would hit me. It didn't break me, but it left me petrified, powerless, and resentful.
And that was always kind of there. But we also loved to fish. I kind of grew into loving to fish with him.
So when Jimmy made that discovery in the lab, he thought of his dad.
What I suddenly realized was that obstacles could actually help you struggle less. I could let my father be himself without giving up on myself. This is different from forgiveness. It's the way I choose to define the events in my life, by my response to them.
It was a real turning point for Jimmy. And ever since, he's had this sort of private habit.
Because that's what I do all the time is I've got fish on the brain. And somehow when I'm sleeping or whatever, they kind of cross over. And then I find myself trying to go down the path of the science to see if that would answer anything in my personal life. And at some point it gets way too technical. I'm like, well, this has no relevance to my life. But other times I'm like, this question's kind of been solved, maybe similar to what you guys are doing with misinformation and fish. Maybe it exists, right, in the world. And if you just have an open enough mind, you might be able to learn from it.
This is a show that deals with big human problems. And misinformation is one of the biggest. It can also feel like one of the most human, but it's not. All sorts of animals deal with all sorts of misinformation every day. So we thought, hey, why not ask the fish what to do? This week on Things That Go Boom, we are exiting the human world entirely to see what we can learn. Hey there, a quick favor. Things That Go Boom is conducting an audience survey, and we'd be so grateful if you could take just a few minutes and fill it out. If you're in, please visit survey.prx.org/boom to take the survey today. That's survey.prx.org/boom. Thanks. People have studied animal behavior to learn about our world for literally thousands of years. And today, Jimmy Liao says there's a million ways to do that.
For me, in my little small field of biomechanics and neuroscience, we study the individual fish. We're enamored by actually what makes a fish work. What does it sense? How does it swim? How does it breathe?
In terms of ability, there's fish that can fly out of the water, crawl on land.
There's fish that can live in the Antarctic waters. They can live in 100-degree weather. There's so much diversity. I think it's limited by the lack of people studying it.
Jimmy tends to encounter this idea about fish in the human world. It says that they're primitive or simple, stupid even. And yet, we owe everything that we have to them.
The first animals that have a backbone, which includes us, happen to be fish.
Hundreds of millions of years ago, our fish ancestors crawled up onto the shore where their fins became limbs, and they somehow figured out a way to breathe air.
With a fish, you might loosely think of it as a very simplified human being. The regions of the brain, the anatomy, that's all kind of shared by humans. So a lot of times when it's really difficult or challenging to study something in a human or a rat or something like that, people study fish.
This type of research has potential major reach. Studying fish could help us understand human diseases, evolution, and yes, even maybe information itself. See, when we think about mis or disinformation in humans, we tend to think about the way that it happens to us. Say somebody on TikTok's trying to sell you some weird supplement or a stolen election, which makes sense in the security world. But scientifically, that means that we're skipping over a pretty important part of the equation: nature.
I grew up in Tallahassee, Florida, kind of in the woods. I had one of those childhoods that was just like, all right, go ride your bike and see you when it gets dark.
When Ashkaan Fahimipour was a kid, his hometown was in the middle of a big change. Northwest Florida had always been fairly rural, but in the 90s, he noticed all of this new development in the area. Tallahassee was starting to look more and more like a real city.
I think seeing that really fast growth of a city in the same place where I was running around playing with lizards and stuff, I think it really affected me. It really made me passionate about trying to help preserve biodiversity. I was really fascinated by these very basic questions that biologists have been asking for more than a century, but actually we've made surprisingly little progress on. And these are really basic things like, how does an ecosystem come together, and how does it change in time, and how does it fall apart?
Today, Ashkaan is an ecologist at Florida Atlantic University, and he says that this is really important stuff for us to figure out. If we understand our ecosystems, we can manage our environment better, conserve resources. It's all just casually important intel for our burning world.
If you imagine someday we want to go colonize Mars, we would need to know how to create a living, functional ecosystem. And so even kind of these sci-fi things, I started realizing everything is ecology, and I really wanted to understand them from this bird's eye systems level perspective. I've worked with bacteria, insects, the dust bunnies under your couch, air vents in a hospital.
That's a very disturbing thought, both the couch and the air vents. Thank you very much for that.
But my work takes me to a lot of cool habitats. I do much prefer doing field work in the coral reefs of Curacao over vacuuming dust from a bathroom in a hospital.
Like Jimmy Liao, Ashkaan also studies aquatic behavior. And to do that, he uses computational biology, which is a very scientific way of saying that he is an international ocean spy.
So this study was done in Moorea, French Polynesia.
Or maybe instead, a reality TV producer.
And the fish are the stars, yeah.
But how do you then begin to dig down and understand how they're reacting?
There have been a lot of different approaches for doing that sort of thing. The one that my colleagues and I have been working with recently is kind of this really fancy high-tech. It's definitely a modern way of doing these sort of animal behavior studies. And the thing that we do is we gather a large volume of high-resolution video data from underwater.
And to do this, they build sets rigged with tiny little cameras in the ocean.
You can imagine something like a big PVC frame over the coral reef with cameras at every junction of the frame. Sometimes we have these light pole looking things that are kind of cinder block bases with big poles with cameras on top.
And the hope here is to catch fish being their most authentic selves.
Occasionally we do things like we'll bury iPads down there as well so we could play the fish certain videos.
Like simulations of a predator attacking the fish.
And actually they will respond just as if it was a real animal to the iPad videos. And then we use AI algorithms, various ones from companies that people are familiar with, like Meta, to extract information automatically from these videos about what these animals are, how they're moving around their environment. So Meta trains this on like pictures of your baby shower. We train it on underwater images to learn how to find fish in these coral reef videos.
And the point of all of this fish spying can be surprisingly similar to Meta's. It's about gathering intel on how communication itself plays out, and also a little bit about studying their social networks.
They're not like sharing information about each other's backyard barbecues or anything sophisticated like you would think of in a social network, like online or actually in the real world. But they do share quite a bit of information amongst each other. And this could be information about, say, something like an approaching predator or the location of some good food or, this is my territory and stay away. So there are all kinds of ways that these animals in the wild communicate, and kind of collectively these form massive social networks.
Animals all over the world do this. But lately, Ashkaan has been especially interested in Earth's tropical ecosystems.
Shout out to parrotfish for sure.
The parrotfish is a real beauty queen of a species. They're these shimmery turquoise creatures that can be huge, up to 4 feet long. Plus, their faces do kind of look like a bird's. And as it turns out, they are also constantly trying to figure out what is real and what is not.
These fish experience misinformation all the time. On the coral reefs that we study, we estimate that they experience one of these misinformation events about every 8 minutes.
So if one pictures themselves as a beautiful parrotfish, say we're hanging out off the coast of Australia.
So I'm a fish and I'm eating algae and it's delicious, and I'm kind of worried about predators in the area. So I can look out for them, but also I can keep an eye on what my neighbors are doing. You can imagine it like you're walking down the sidewalk with a friend, and all of a sudden they start sprinting the other direction down the sidewalk.
You might take a beat, look around, try to figure out what's happening.
And so one of the things that they really, really need to avoid is responding to the case of a false alarm. So one of my neighbors made a mistake and thought there was something scary, but there actually wasn't. We had some data that was pretty convincing that this is a real major problem for these animals, these false alarms, even more than I think was previously appreciated. That's a really important job for their brains to solve, because those false alarms are extremely costly, so costly that in time it could be the difference between life and death. We set out to understand how they were able to, living in this world where, you have your face down in a mat of algae and you're eating, and you got like an eye out for predators, an eye out on your friends to see what they're doing. How are they integrating all of this different information about their world, including some of it from social ties, to make these decisions about when to start or stop eating or run away or hide, or the basic things that they need to do to survive and reproduce?
And what they found was that fish are actually really good at spotting false alarms. But unlike humans, they don't rely on fish influencers, and they don't keep track of who has a reputation for crying wolf.
Their brains are capable of almost pulling out hidden features of the way that their neighbors are communicating with them. And the way that they do this just so happens to help them discriminate against misinformation.
But how? After the break, why do fish seem so good at misinformation? And can we actually learn anything from that? You're listening to Things That Go Boom. You're hearing the sounds of Curacao, where Ashkaan's team just staged their latest study. The water is beautiful. It's neon blue. There's all this algae and seaweed swaying in the current. And then a little school of small gray fish swim by. And they're swimming in exact unison. Even the space between them looks perfect. And often when Ashkaan sees this sort of fish footage, he sees math.
I have come to learn that they are capable of surprisingly complex computations at the level of the individual. They happen at the level of groups. Things even as simple as like what we would call schooling is a coordinated swimming that involves interactions between the brains of multiple free-moving animals.
And when something goes wrong, say there's a threat, these animals have milliseconds to decide if a danger signal is true or not.
The fish escape maneuver is controlled by a single giant neuron in the back of the brain. And if this neuron fires, it's almost like a reflex. They will bend into a C shape and fire off in the opposite direction. So there's this direct metabolic cost of actually, you can imagine having to do a high performance sprint maneuver.
And it turns out there's actually evidence of more insidious problems in nature than just false alarms.
There are actually like multi-species misinformation and even what I would consider disinformation in animals. So, for instance, other animals mimicking the alarm calls of another species to trick them into, say, leaving an area where there's lots of food. Those are some kind of classical examples in evolutionary biology that have been around. But I think every day we are discovering more about how animal cognition works in groups. And each time one of these studies is published, we learn something new about both challenges that animals have to face living in kind of a social world and their solutions to these problems.
In our world, you might name the emotions of the moment. I felt scared, uncertain. But as far as we know, fish don't do that. Instead, they run this totally automatic web of math in their brains. And all of that equals out to how they will react. And the reason why we know this actually started with some old computer games.
Back in the 80s, there were these first-person shooters, and these were games like Doom and Wolfenstein. And these would be kind of shockingly on the computers at your school, despite the inappropriate violence level for a second grader or whatever. And this is such like a 90s kid story, I guess, but games are actually like a technological marvel. They have developed numerous highly efficient algorithms to solve different problems in these games.
One famous example is a way to solve for the square root of a number.
One of the things they needed to do was go from an overhead perspective of the level, which is how the game designers would design things like walls and stuff in a level, from the first-person perspective of the player.
See, the designers wanted to make more immersive games, where the challenges were based on what the player was actually seeing in each moment. You weren't just some third-person observer, you were the character, which meant creating an algorithm that tracks exactly what you're seeing.
You go to the eyeballs of the player and you shoot out discrete rays, so like straight lines in every direction. And anytime the ray collides with another thing in your video game, so a wall or another character, it takes note of that.
And if you take all of the times that your eye lasers touch something in view and add them up,
you can recreate the first-person perspective.
For that guy walking around killing things on Doom, or if you're Ashkaan, for a whole bunch of fish.
If you have what the animals are seeing, and then you have what the animals are doing because you watch it on these videos, then you could fit mathematical models that explain what happens between those two steps.
And when you use your Doom raycasting and your mathematical models to learn more about how fish react to misinformation, well, what it seems like is that the fish themselves are also using some really specific algorithms to suss out danger signals.
And the forms of these mathematical equations actually are what lends their decision-making process so much robustness against this misinformation.
So imagine we travel back to our scene on the coral reef. Somebody thinks they've seen a predator and they decide to dash. But it's actually a false alarm.
So the false alarms, they spread contagiously, right? You see someone running down the sidewalk, Maybe, you don't even ask questions. You start running with them. Someone else sees the two of you running and joins. So these false alarms cascade through the social networks, almost like a contagion. So we noticed that they were happening constantly. But then we also noticed that despite the fact that they were happening constantly, they were seldom spreading very far through the social network.
And when the researchers ran everything they collected through the equation that seemed to control how fish responded to a threat, the computer correctly predicted the behavior of almost all of the animals in the study. How? It figured out that all of these fish were really good at questioning everything they saw. Nothing gets taken for granted under the sea. Nobody is permanently reliable or unreliable.
The best analogy I can make is imagine you're at a cocktail party and you're having a conversation with someone, but the party is really loud. And so what your brain is having to do is kind of cancel out the background and tune in to the person you're having a conversation with. Now you can imagine that another time you're having a conversation with somebody in a very quiet room. And in both of those situations, your brain is able to focus on the person you're speaking with and almost tune out the background.
The brain picks out what it thinks you should focus on and tunes out the rest.
And something similar to that happens in the visual system. You can imagine if you go from a dark room, you step outside and it's really sunny, you go blind for a minute until your eye adjusts to the new sensory background of your new environment, and it takes a little bit of time.
These equations seem to protect the fish from getting caught up. So one fish can make a mistake, but the other fish, seeing the situation from different angles, won't necessarily follow suit. That prevents the herd from falling into chaos at every perceived threat. And that fish that swam off, well, they can make their way back into the fold.
The form of these mathematical equations is what you would write down if you were writing down a system with that property, this adjusting to background noise level and the ability to do that. So it is not a complicated equation. It's surprisingly simple, and it's seen kind of surprisingly frequently in different places in biology. It appears in neuropsychology. It appears in responses to noise, auditory stimuli. It appears in visual responses in vertebrates and invertebrates.
I'm no scientist, but that urge to run with any piece of mass information and the feelings it stirs up, it feels kind of baked into our lives at this point. But other times I wonder, has every generation felt this way?
If I needed to speculate, I would probably guess that this is such a fundamental challenge for the animal brain, and we see it, not necessarily this behavior exactly, but other similar behaviors in so many different kinds of animals. So I think that there is a lesson that we can take from this study. And it comes from the observation that the way these animals have solved this problem of misinformation is to tune down their sensitivity to the information they're getting from their social ties when they're just receiving too much of it. If you find yourself in a situation where you're being constantly bombarded by information from your social ties, it might be beneficial to take a moment and step back and assess the situation yourself before making any decisions.
It seems like when these animals think for themselves, that contributes to the successful behavior of the group. But there's always this concern among scientists that we should be careful not to project our problems too far onto nature, even though we are nature.
I think the biggest kind of point of caution that I have considered so far is that there is a big distinction between misinformation and disinformation. And I think the intent, the deliberate misleading is kind of the thing that separates them. And that although I gave an example earlier of a case of disinformation in the animal world, I would say it is probably less common and less salient than, for instance, for human societies. And so I would worry about falling into the trap of, these fish have all of the answers for us, because they are dealing with a fundamentally different problem. That said, I do think that we can learn something about how animal brains, just at a fundamental level, deal with these sort of problems. But I would be cautious about kind of bringing those lessons into how we manage human societies without kind of much more mature research.
When I asked Jimmy Liao about how you'd even do that, we arrived at a sort of spooky question.
How do you break a fish? How do you, get to a point where it's like, oh my God, I don't know what the heck's going on. Maybe that's the analogy. The more confusion out there, the harder it is. Because usually with fish, I imagine, like, we're seeing which sensory, modality rises up in priority. But in reality, it's not that confusing in a fish world. Like, you don't get water that just reverses all of a sudden or just whatever, right? Their eyes are telling them something that the lateral line is also supporting. And in the occasional instance, like, they might be conflicting, so then you have to choose one or the other.
But in the human world, the misinformation layers on top of itself. One man's false alarm easily becomes another's chance to deceive. Platforms have made that process seamless and available to everybody. Plus, let's be honest, people just don't trust leaders like they used to. We hem and we haw about what should be done, but sometimes even that can make the problem feel worse, louder, like a school of parrotfish pinballing in every direction.
How do you navigate that? How do you make sense of that?
You're just like complete sensory overload all the time.
And then so the experiment I would do for a fish would be then somehow let's create that total overload. And do the fish just freeze? Do they just kind of like give up? They're just done, and then once they're done, can you get them to do something else a lot easier? Because all of a sudden you just hit the reset button. Like, that's who knows.
And the fact that you could run that experiment and potentially replicate how crushing information can feel these days, it's oddly comforting. Because instead of thinking about misinformation as our inevitable harm, our end, I can think about it like an inevitable struggle. And I think we can do something with a struggle.
It's like this relief that, like, if once misinformation comes, it's not like a virus that's just like an instant extinction of the species, right? It's like there's some way, life, finds a way to get past this. Can we mine the natural world for ways of how they solved it, and can we incorporate that? It's hard for people to grasp, I think, sometimes the interconnectedness of everything, but also the sheer depth and complexity of the biological world, especially in a kind of capitalistic society. People think the more money you throw at it, like, you should be able to demand an answer. Like, we should get an answer for, $50 million, right? Like, that's a lot of money. You could build a lot of stuff with that, but it doesn't work that way. Like, there's a handful of scientists that are like peering into the unknown and using our best intellect and intuition to kind of solve these things. And that's been something I've been more recently trying to do, is get the public up to speed on how daunting, but also maybe exhilarating it is to stare into such complexity.
Things That Go Boom is distributed by Inkstick Media and PRX. Don't forget to send your questions about the internet and security to Boom at inkstickmedia.com, because we're going to answer them in a special Q&A episode later this season. And while you're at it, don't forget to leave us a review, because they really do help folks find our little show. This episode was produced by Christina Stella and me, and it was edited by Katie Toth, Nikki Galtland, and Sahar Khan. The music for our show is written by Darian Schulman. Thanks, as always, to the supporters and foundations that make our work possible: the Carnegie Corporation of New York and Plowshares Fund, as well as Inkstick supporters, including the Cologne Foundation, Craig Newmark Philanthropies, Prospect Hill Foundation, and the Jubitz Family Foundation. In 2 weeks, we'll be asking what happens when the government turns off the internet. See you then.
Fish are so wise.
Yeah, it's so wise. Next time you're in the aquarium, take a moment to appreciate the wisdom of these fishes.